Hey everyone, ready for another deep dive. Today we're going to be looking at how changes to the seafloor can actually have a big impact on, the coastline.
Yeah, it's pretty fascinating stuff.
Yeah, so we're focusing on Dundrum Bay on the coast of Northern Ireland.
Right.
And, as always, tides, waves, and currents are all shaping coastlines, but the study is really going to highlight how those underwater changes can have some pretty big effects, on the beach itself.
Exactly.
So we're looking at a 2004 study by Cooper and Navas. It was published in Geology, and they use old maps, aerial photos, even underwater surveys to really piece together the history of Dundrum Bay.
Yeah. And what's so intriguing about Dundrum Bay is that we have this really unique opportunity to see how those changes on the seafloor itself,
Yeah.
something you don't normally get to see, can lead to some pretty dramatic shifts in the coastline.
Yeah, for sure. So let's set the scene a little bit.
Oh.
Dundrum Bay is on the southeast coast of Northern Ireland.
Right.
And it's kind of this beautiful mix of sandy beaches, dunes, and a tidal inlet that connects to the Irish Sea.
Yeah, and it's a really dynamic environment. Yeah. Dundrum Bay experiences a pretty wide range of tides, what we call mesotidal to macrotidal,
Okay.
basically meaning that the bay experiences a wide range of tide heights, and it's exposed to some pretty strong waves, especially during those southeasterly storms. It's a place where the land and the sea are constantly kind of pushing and pulling on each other.
Wow. So how did researchers figure out what was going on beneath the surface? I'm picturing them in some kind of special submarine poring over ancient nautical charts.
Well, they didn't have a time machine or anything like that,
Okay.
but they did use a really clever combination of historical maps going all the way back to 1835 aerial photographs and good old-fashioned, on-the-ground observations
Wow.
to kind of track how that shoreline has changed over time.
That is fascinating. So how did they actually measure the changes in the shoreline using those old maps?
So basically, they digitized those old maps and aerial photos,
Hmm.
which allowed them to compare the position of the shoreline, at different points in time.
Makes sense.
And what they found was really interesting. The northeast end of the bay was actually expanding outwards. Both the high and low tide marks were moving further out to sea.
Oh, wow.
But on the southwest side of the bay, it was a totally different story.
Really?
That area was mostly stable or even eroding in some places.
That's interesting. Couldn't other factors also be contributing to those changes, though, like changes in rainfall or even human development along the coast?
You're absolutely right. It's a complex system. There's a lot of different factors at play.
Yeah.
But the researchers were able to kind of isolate the impact of the changing seafloor by really carefully analyzing the data and controlling for those other variables.
So it sounds like the changes on the seafloor were really the dominant force driving those shoreline changes.
Exactly. And those changes were even more dramatic near the inlet.
Yeah.
A spit, basically a natural jetty made of sand, had formed sometime between 1863 and 1904, and it's been steadily growing ever since. Meanwhile, on the other side of the inlet, erosion was becoming such a problem that they had to install rock armor in the 1980s to try and protect the shoreline.
So speaking of dramatic changes, didn't you mention something about rapid beach growth at Ballykindler? What's happening there?
Ah, yes. Ballykindler. That's another great example of how changes on the seafloor can impact the coastline. You can actually see the evidence of that rapid beach growth in the form of these really impressive four-dune ridges that are up to 150 meters wide.
Wow.
Think about that. All that sand is piled up just since the 1930s.
It's amazing. So we have this changing shoreline, but how did the researchers actually connect those changes to what was happening on the seafloor? Did they have to, invent some kind of special underwater time machine to see how the seafloor itself had changed over time?
Well, it wasn't quite a time machine,
Okay.
but they did have access to something pretty special. They had bathymetric charts from 1861 and 1968,
Okay.
which allowed them to compare how the shape of the seafloor had changed.
Okay.
What they found was astounding. A net gain of 43 million cubic meters of sediment in the subtidal zone just between those years.
Wow. 43 million cubic meters. To give you an idea of how much sand that is, imagine filling the entire Empire State Building to the brim with sand. Now multiply that by 12.
It's a lot of sand.
Where on earth did all that sand come from?
That's the million-dollar question.
Yeah.
One theory is that it may have come from a large offshore sand deposit that was formed during the last glacial period. Essentially, it's like this giant reservoir of sand that's slowly being moved around by currents.
So Dundrum Bay had a major sand delivery at some point. That's a lot of change happening under the surface.
Yeah, it really is. And that brings us to how researchers figured out how all that extra sand ended up changing the shape of the coastline. So They use something called the Hussawa wave model
Hmm.
to simulate how waves would have moved through the bay with both the old and the new seafloor shapes.
Okay, so is that similar to those computer simulations that they use to like predict the weather?
It's exactly, yeah, it's basically a sophisticated computer program that uses data about the shape of the seafloor and other factors to calculate how waves are going to propagate.
Okay.
And the researchers in this case focused on what happens during storms because, those are the events that really drive sediment transport
Yeah, it makes sense.
and cause, the biggest changes to the coastline.
That's interesting. It just seems like the storms would be the key factor no matter what, but I guess the shape of the seafloor would kind of determine where all that energy is focused.
Yeah, you got it. And what they found with that Hiswa model was fascinating. So the simulation, using the 1861 bathymetry, before all that extra sand arrived, showed waves kind of dissipating their energy pretty evenly across the bay.
Mm,
But with the 1968 bathymetry, after all that new sediment arrived,
right.
the simulation showed wave energy being concentrated more towards the northeast. And this actually created a clockwise circulation pattern within the bay.
Oh, wow.
Almost like a whirlpool, you could say.
So it's like the buildup of sand on the seafloor created a kind of ramp that changed how the waves moved through the bay.
Yeah, that's a great way to put it. And, that subtle change in how the waves moved had this huge impact on where sediment was being deposited and eroded.
Hmm.
So think about it. We have the Spit Formation, the inlet migrating towards the northeast, and all that beach growth at Ballykindler. All of those are connected to this shift in wave patterns caused by that changing seafloor. It's like this domino effect, with that extra sand being the first domino to fall.
It really highlights how interconnected everything is. You can't just look at one piece of the coastal puzzle in isolation. You really have to consider the whole system.
Absolutely. And that's one of the key takeaways from this study. It really challenges us to think differently about how we analyze coastal change.
I'm starting to see why that's so important, but didn't you mention earlier that while the northeast part of the bay was growing, the area near Newcastle was eroding? How does that fit into the whole picture?
Yeah, that's a great question. So while the overall trend was for the northeast to gain sediment, the southwest near Newcastle was actually experiencing some localized erosion. And this just goes to show that even within one small bay, you can have very different patterns of change happening at the same time, all driven by these subtle shifts in the seafloor and how they influence wave patterns.
So it's kind of like a seesaw with one side going up and the other going down.
Exactly.
Okay.
And that's where a lot of traditional analyses of shoreline change might be missing a crucial piece of the puzzle.
Mm.
They often just assume that the offshore conditions are constant, you see.
Right.
But this study shows us that that's just not true. Changes in that nearshore bathymetry can make a world of difference.
It makes you wonder how many other coastlines around the world might be experiencing similar changes without us even realizing it. We might be focusing on the waves and the tides, but completely missing what's going on beneath the surface.
Yeah, that's a really important point. And this really underscores the need for more research in this area.
Mm.
We need to get better at understanding how those changes on the seafloor are impacting coastlines, especially, as we face the challenges of rising sea levels and, increased development along our coasts.
Welcome back, everyone. We've been talking about how changes in the seafloor can really reshape the coastline of Dundrum Bay. It's kind of crazy how much is happening below the surface, isn't it?
Yeah, it really is.
It's like we're only focusing on the tip of the iceberg and not that massive hidden structure underneath.
Right. It's a fascinating case study. It really highlights how much we still don't know about the complex interactions that shape our coastlines.
It makes you think, like, what about all the stuff we humans are doing out there?
Yeah.
Making things even more complicated.
Oh, for sure.
Things like building wind farms, laying pipelines, even like extracting sand for beach nourishment projects.
Absolutely. All of those things have the potential to alter, those sediment transport patterns
Right.
and trigger changes in the seafloors.
So how do we make sure we're not like accidentally causing more harm than good? Like, how do we use what we learned from Dundrum Bay to protect other coastlines?
Well, I think the Dundrum Bay study gives us some really valuable insights.
Good.
For one, it really emphasizes the importance of understanding the interconnectedness of, the whole coastal system.
Right.
We can't just focus on what's happening on the shoreline. We need to be looking beneath the waves, too.
So what does that look like in practice? Like, are we talking about more underwater surveys, more sophisticated models?
Oh, that's exactly. You hit the nail on the head. All of those things are important. We need to be gathering more data about what's happening, both above and below the waterline.
Right.
We need to develop better tools to analyze that data and predict how coastlines will respond to different pressures, both natural and those caused by humans.
It's almost like a call to action for scientists, engineers, and policymakers to all work together.
It is. We really need that collaborative approach,
Yeah.
you know, to tackle these really complex challenges. And we also need to move beyond just assuming that the seafloor is static. We need to incorporate this understanding that it's dynamic,
Right.
ever-changing nearshore environment
Right.
into our management practices.
So it's not just about studying these processes, it's about actually using that knowledge to make smarter decisions about how we manage our coastlines.
Yeah, absolutely. That's where the rubber meets the road, so to speak. That's
Okay.
what makes this research so important. It's not just about understanding the science for the sake of knowledge. It's about applying that knowledge to make a real difference,
Mhm.
out there in the world.
This whole deep dive has really opened my eyes to the crazy way that our coastal environments work.
Yeah.
It's so cool how much is happening below the surface that we don't even think about. It's like this
Right.
hidden world down there that's shaping the world that we see above.
Yeah. Yeah, that's the beauty of science, right? It allows us to kind of peek behind the curtain and see the world in a whole new way.
Hmm.
And, the more that we understand about these systems, the better equipped we'll be to protect them,
Yeah. Right.
for future generations.
I love that. So as we wrap up our deep dive on Dundrum Bay, what's one thing that you want our listeners to take away from this episode?
I think the big takeaway here is the next time you're at the coast, take a moment to look out at the ocean and really think about all the unseen forces at work beneath the waves.
Hmm.
All those forces are constantly shaping and reshaping our coastlines. You know,
Yeah.
and it's really up to us to understand those processes and, respect them if we want to ensure the health and resilience of our coasts for years to come.
I love that. Well, thank you so much for leading us through this incredible deep dive. It's
Hmm.
been so eye-opening. And to all our listeners out there, thanks for joining us. And until next time, keep exploring and keep learning.